Good day everyone. We will discuss about range high key intra-step hit, statistic scaling, and parameter sniffing for stored procedures in this video. Let's get started. I'll be using database JBS wiki for this. I'm going to execute this particular query. What I'm basically doing is I'm trying to select a column SNO from table color with a predicate of color, and I'm using a local variable here. So the local variable I've set the value as color 62. So let's enable the execution plan and then let's execute it. And now let's look at the estimated number of rows for this index seek, and what I'm able to see is it is 353.96. So what I'm seeing is the value for the estimated number of rows for the index seek is 353.96. So what we'll do is we will look at the statistics and then see from where we are getting this particular value. So since we have used the predicate as a color 62, and for the column color, we have the statistics on the color column, which is IX test. So I'm going to query that. And if I go to color 62, since that's the predicate value that we have used, and what we are able to see is as far as color 62 is concerned, we don't see that value at all, that the 353.96 value. We are not able to see that at all here. If you look at it, like for color 62, the range rows is 297 and EQ rows is 63, distinct range rows is 5, and then the average range rows is 59. The reason why we don't see this is the SQL Server Optimizer will understand this particular value. That is, when we use a local variable, whatever value that we are going to provide as far as this local variable is concerned, that will be understood only during the runtime. So an execution plan will not be created based on this particular value. So the estimates will not be created specifically for this particular value, since we are using a local variable. So instead, what we do is in case we utilize a local variable, so what happens is it basically gets the density value. In our case, it is going to be 0.0028, and this will be multiplied with the a number of rows on this particular table. So basically the calculation would be the density value into, that is, multiplication, select count one of the color table. So if we look at this one here, what we can see is this is basically the density value, and we are basically multiplying this density value with the row count for colors table. So let's execute that, and what we can see is we are getting an estimate of 353.96, which is same as what we got it here. So if you want to look at it again, let's execute that. And then if you see here, the estimated number of rows for all execution is 353.96. Moving on. So what we'll do now is we will try recompiling this query just to understand if we can we'll find what values right now if we use and recompile it. And if I execute this query, now I hover my mouse on this index seek. What I'm seeing now is I'm no longer seeing 393.56, instead 353.96. Instead, I'm looking at a value of 63. So now what happens is since we use the recompiling, optimizer will be able to get the information as far as this value is concerned. That is, a plan will be created based on this particular variable. That's the power of recompile. So now we look at the statistics value, and I go to color 62. What I can see is I'll be able to see 63 under EQ rows, which is basically used for the estimate by the optimizer. So moving on, what I'll do now is let me disable the execution plan, and then what I'll do is I will insert close to 5,000 rows specifically for color 62. What we understand is we have close to 63 rows already for color 62. That's the estimate that we got. So now what I'm going to do is like I'm going to add another 5,000 rows, just making sure like the automatic update statistics is not kicking in. Yep. And then now let me enable the execution plan, and I will execute the same query as last time. So last time I used the recombine imp. This time I'm basically giving the value directly. So let's look at it. And what I'm seeing is like this time the estimated number of rows is close to 65.5. It is no longer 63. And also like we know like we inserted close to 5,000 rows. So the understanding is like whenever after the update statistics, when huge rows are inserted or some changes is happening onto the table, what happens is like we basically the optimizer basically will not take the values directly from the EQ rows. Instead, what it does is like it basically looks at the selectivity, and depending upon the selectivity value, it basically like performs the calculation. So let's look at the statistics value here. What I'm able to see is like um, for color 62, we will be able to see that the EQ rows is close to 63. So I'm putting that value here, and then I'm going to insert the total number of rows that is present on the output here. So I'm going to run that, and I will be getting the selectivity value, which is basically 0.00050564. So what I'll do now is like I will multiply this selectivity value with the number of rows on that particular table. So let me execute that. And what I'm seeing is like I'm getting a value of 65.52. This is the value that I'm seeing. And if I run this query again, what I'm seeing is like I'm getting an estimate of 65.52. So this is where we got this particular value. Okay, so what we'll do now is like we will basically like run this particular query, and this time after the rows were inserted and the statistics are not updated, let's run this query and then look at the estimates now. And what I'm able to see is like I'm getting an estimate of 368.165. So where did we get that value? It is 368.165. 165. Okay, so let's look at the statistics again. So this time, since we are using local variable, so what we will be doing is like we will take the density value and then multiply that with the row count on this particular table. So if I do that, I'm getting a value of 368.164. Since we have a 7, it is going to be round off, so it is going to be 368.165, and which is same as what we saw for this particular query. So just to ensure that, let's go to this one, and we are able to see 368.165. That's same. Cool. Now what I'll do is like I will basically update the statistics for colors table with full scan and also recompile the object color. So now what I'm going to do is like I'm going to execute this particular query with the execution plan, and what I'm able to see is like I'm able to see that I'm estimating close to 5063 rows. That's what the estimate is. So let's execute this statistics, and then let's go to color 62, and what I'm seeing is like the EQ rows is 5063, and that is where I got the estimate for this particular query. Now what I'll do is like I will utilize a local variable, and then let me look at the estimates now. So now this time I'm getting an estimate of 368.165. So how did I get that? It's basically your density value, and then you need to multiply that with your let's take this just to make sure I'm not typing it all over again. So you need to multiply your density value. If I execute this, I will get the all density value. What I'll do is like I will multiply that with the number of rows on the table, and what I'm getting is like it is 368.164. So if I see here, and let me execute this query again, and what is the estimates here? It is 368.165, which is basically same as this. Yep. Now if I run this query, now even though I'm using a local variable here, what I'll do is like I will execute this with the recompile hint, and what will happen is like if I look at the estimates, it's an estimate of 5063, which again we know like where it came from. Since it's a recompile hint, it was a direct hit at the histogram step, and color 62, the EQ rows is 5063, and this is where we got the estimates. Yep. Moving on, what we'll do is like we will create a stored procedure called color, sp underscore color. And what I'm basically doing is like it is having a parameter of color, and then I'm running and select SNO from the table color, where color is equal to the parameter from the stored procedure. So let me execute that. If I do it one more time, it is all done now. So what I'm going to do is like I'm going to clear the cache. Please don't do that on a production server. It's a lab machine, so I'm doing that. If you do it on a production server, all the plans from your procedure cache will be like lost, and that is going to have some performance impact for sure. So let's not do it on a production. So I've enabled the execution plan. So I'm going to execute this query with a color 57 as the parameter. So now if I run this, what I'll be able to see is like the estimate seems to be close to 58. The estimated number of rows is 58. So let's look at from where we got this value 58. So since the predicate is color, IX test is a statistics where you have it. So let me go to color 57. So color 57 is yeah. So what I'm seeing is like there is a direct hit on the histogram, and the EQ rows is 58, and this is where I got my estimate for this particular query. So what I'll do now, I will execute this particular these two queries so that I will be able to see next to each other. So what I'm seeing here, this query is estimating 58 number of rows, like that is the estimated number of rows is 58, and the actual number of rows for all execution is also 58. So it's a good one. Like I was able to do a very, very good estimate. Now look at this one. What I'm able to see is like I'm estimating close to 58 rows, but I'm returning close to 5063 rows. So it's like my estimate is off by 10x. Like I estimated it's like not even 10x, 100x. Yeah. So I estimated 58 rows, and but in reality I have to return 5000 rows. Yeah. So now what I'll do is like I will just do a right click on this particular thing, and if I come down, what I can see is like I will be able to see all the details with regards to this particular execution plan. And if I check this one, that is when I click on this select here, what I'll be able to see is like I'll be able to see something called parameter list here. So if I look at the parameter list, it basically tells like the plan that I'm using for this particular execution. The execution plan was basically compiled using a value called color 57. So that's the parameter compiled value. But right now I'm executing this particular query with a parameter of color 62. So for example, if you want to check if there is a parameter sniffing issue, what we can basically do is like we can look at the execution plan, go to the parameter list, and you can compare the compiled value and runtime value. If these things are different, then that means like we compile this plan using a different value, but running it with a different, currently executing this stored procedure with a different value. So there is high possibility this could be a problem. But if these two things are same, then that means like basically like there shouldn't be any problem as such. Yeah, that's one thing that will really tell us like whether there is an parameter sniffing issue or not. Moving on, what I'll do is like I will insert close to 10,000 rows into this table for color 57. So we already know like there are 58 rows because of this estimate. Now let me insert another 10,000 rows here. Let me remove the execution plan. So what we can do is like we can again run this query. Maybe like I will recompile, we will recompile the stored procedure, and then we will execute the stored procedure, and then we will look at how the estimates are. Let me pause this video, and I will let you guys know once it is completed. Yep, it is completed now. So let me recompile this stored procedure here, and then let me execute this query, the stored procedure with color 57 as a parameter with the execution plan on. So now if we look at the execution plan, what I will be able to see is like I'm seeing an estimated number of rows is 62.4, and in reality actually I have like returned close to 10,058 rows. Yeah, that's what I've done. So let's check where did I get this 62.47 value, 62.47 estimate. So let me execute this query, and I will go to color 57. So now if I go to color 57, what I'm able to see is like I have EQ rows of 58, but I know that after the last update statistics, I've inserted some rows. The optimizer knows that, so it will not be using the EQ rows this time. Instead, it will be going for a selectivity value. So inserting the EQ rows for color 57 in the histogram step, and then let me bring in the number of rows, and then let me put it here. Let me execute that, and then I will get the selectivity value. After that, what I'll do is like I will multiply the selectivity value with the count for that particular table, and what I'm getting is like I'm getting a value of 62.47, which is same as what we saw. So what we are seeing is like it is 62.47, and then let me 62.475. If I run this query, 62.475 is the estimate, and if I look at the estimated number of rows, it is 62.475. So both are same. So this is how the optimizer got its value. Yep. And moving on, what I'll do is like let me execute this particular query here and look at the estimate there. Yep, let me look at the estimate for the hash join. So if I look at it here, what I'm able to see is like I'm able to see an estimate of 352. If you guys can see that, the estimated number of rows is 352. So let me execute this and get the details for statistics on color. So what I'll do is like I would pin this one here, and what we can do, let's execute it, and then what we will do, we will get the density value, and then we divide 1 by the density value, and then let's see what we get. We get 352. So that's the estimate that we saw for the hash join. Let's check that again. So if you see here, the estimate is 352. So the calculation by the optimizer, that was a calculation. It was done by 1 divided by the density value, and it came up with this particular estimate. Let me drop the procedure here that I've created. Thanks for watching. Have a great day. Jai Hind.